Hello everybody, this is Mr. Basil, and let's get to it. So this is your video notes on learning target 5.5 at the approaching level, which is all about the types of reactions. Now, this video is just to get you the main idea of what the 5 different types of reactions are. If you already know those, feel free to skip this movie or this video and go on to the next one, where we get into predicting products. But if you don't know what synthesis, decomposition, and so on are, this is what this video is for. So the essential question for this video is, what are the types of reactions and how do you identify them? Sounds pretty good. So I've got the five different types of reactions here: synthesis, decomposition, single replacement, double replacement, and combustion listed here. We're going to fill in examples of particle diagrams and generic equations over here. So go ahead and pause the video right now and get this structure set up in your notes now, and then that way you're going to be able to follow along just a little bit easier. So I'll wait for a couple seconds and then we're going to get going. Alright, hopefully you have this table done, and let's get to this. So if you did the card sort activity, I've got the pieces of the card sort activity kind of just listed out off to the right here. So let's start with decomposition. I know it's not first, but that's the one you're probably most familiar with just based off of what you already know about decomposition, just the word. So decomposition is when things break apart into smaller things. And so that's this one right here. This one, I'm going to move here. So go ahead and put that particle diagram in for you in your notes. Now, you don't have to get fancy and draw the cubes. They just have to be, maybe make them squares or circles or something. Whatever the case is. Here we have two things that are together, and then over here they separate into two smaller things. That's the idea of what decomposition reactions are. And so over here, the generic equation, where we're just using A's and B's and so on, rather than actual chemicals, that's what we would have. This is what most decomposition reactions are going to look like. Two things that are together, and then they end up apart. And then synthesis is just the opposite of decomposition. So it's two things coming together to make one bigger thing. See how that's opposite? So two become one. And then over here, the generic equation is this. So again, I'm not going to keep saying this, but pause as you need to write this stuff down in your notes. Okay. Then single replacement and double replacement. Single replacement, well, there's one single thing over by itself, and it's replacing the other thing. So if I zoom in here, you can see that, let's go with this color, these two are replacing each other. So this single thing replaces the one that's in the compound over here, and this white block is out by itself, and now it's in with the compound at the end. Okay, so that is your particle diagram for single replacement. So I'm going to move that one right here. It's not perfect, but you got the idea. And then let's see, this one would be the generic equation. It's the same thing. A and B, they swap, right? Well, I guess I should say A and C swap, right? So A is here, it comes over, and then C comes in. A is now single replacement by itself. And then lastly, not lastly, but close to lastly, we got double replacement. So that's this right here. So it's a replacement because, well, same idea as single replacement, you just have two things that are happening. So it's still just one swap, but there's not something over by itself or single. So let's see, these two are the ones that swap this time. So this one that's got the little it's like kind of gray, that one swaps or replaces the one with stripes. And then in the end, they still have partners, so that's why it's double, because they still all have partners, but there's that double replacing that happened there. Okay, so then let's that there, and then this would be the one that goes along with that. Right? Now the last one that's both the easiest and the hardest is combustion. The reason why it's hardest is because drawing the particle diagram is really hard, so that's why there's just a picture of a fire right there. But combustion is just something burning, and so you need oxygen in order to burn, so you're always going to have oxygen as a reactant for this. Now, if you look carefully, you also are going to have carbons and hydrogens as reactants for combustion, and you're always going to have CO2 and H2O for just a normal simple combustion reaction like this. So the reason why combustion is also the easiest is because it always looks the same. There's no generic, I don't have a generic version for this because it's always carbons, hydrogens, and oxygens reacting like this. So that's how you're going to be able to recognize combustions the easiest, because you always have O2 as a reactant and carbons and hydrogens as reactants. The only thing that will be different are the subscripts for the carbon and the hydrogen. So there you go. Those are your 5 different types of reactions. I don't have definitions for these, but you could create a definition yourself based off of what this stuff is, right? You don't need me telling you what these are, because you have these examples here. All right, that's all I got. So thanks for watching, and see you next time.